Hi everyone, my name is Amitesh and in this video we're going to talk about n choose k. What is n choose k? These are called the binomial coefficients. What are they? How to understand them and why they're so useful for understanding and solving counting problems. Now, if all of these terms sound fancy, don't worry. We're just going to go right from scratch and you're just going to go and explain what this means. So if you've seen this notation, for example, something like this, with a 5 and a 2, two numbers stacked on top of each other with the brackets, it appears on calculators, it appears just in general. If you've seen this notation, you want to really understand what it is, even if you kind of know what it is and you want to get an in-depth, comprehensive introduction, this video is for you. So let's just dive right into it and talk about what this is. Okay, so this is going to be, I'm just going to talk about, the topic is going to be called binomial coefficients. Okay, so binomial coefficients are basically terms like this. You could have 5, 2, you could have any number on the top and any number on the bottom. Generally the number on the bottom should be less than or equal to the number on the top and should be a non-negative integer. So for example, something like 13, 8 or 12, 1 or anything like this. Now, before I get into the math part of it, I'm going to motivate you with a very concrete question that can come up in your day-to-day life. For example, suppose you have a class of people, okay? So you have a class of, let's say, 25 people and 25 students, and you want to figure out how many different ways there are of forming a committee of 4 students out of the 25. Okay, so how many different possible choices of committees are there where the committee has to have 4 students out of 25? Actually, the answer to that is going to be 25, 4. Okay, whatever this number means, that is the answer to that problem. Okay, so I'm going to write this out. This is going to be how many 4-member committees there are. 4-member committees there are in a class of 25 students. In a class of 25 students. Okay, now it turns out this can be a pretty big number. Theoretically, you're not going to be able to have all of these committees. If you wanted each one to run for a certain amount of time, you'd have to wait a very, very long time to have all possible committees. As you can imagine, because 25 is pretty big, there are going to be many choices of 4 people in the 25. So that's intuitively clear. What would be cool is if we could just say what that is as a formula. If you could just say, here's what the answer is as a number, without actually going through and counting everything. Okay, so that's what this video is going to be about. It's going to give that formula and understand this. And this is a basic idea in math, but it leads to so much stuff. And it's really, really cool. Okay, so let's just dive right into that. I'm first going to start off with a simpler problem just to give a feel for what we're trying to do. Okay, so let's talk about this number 5, 2. Okay, so 5, 2, this is the number. We could think of it as 2-member committees in a class of 5 students. But you can think of it as other ways as well, right? So for example, if you have 5 letters of the alphabet, like A, B, C, D, and E, how many ways are there of choosing 2 letters from those 5? 2 different letters from those 5. Okay, so I'm going to write it out. It's the same kind of thing. It's just a different way of phrasing it, but it's the same answer. Okay, so how many ways are there? How many ways are there of choosing 2 letters among A, B, C, D, and E? Okay, so let's try to count this. Okay, so let's just actually try to count how this is, and we'll do it from hand. We'll do it the naive way. And then we'll see, this is the beauty of math. There's a naive way of doing this. It may work for small numbers, but it gets quite complicated for large numbers. And then you need to do some magic. And that's the beauty of math, that magic that comes in to understand a general answer. But here, let's just write down some of the ways of choosing the 2 letters. So of course, we can choose letters A and B. So I'm just going to write A and B. Okay. So I'm just going to put a little bit of a curly brace. Okay. This is suggestive notation in the sense that this is used in math. It's just saying that we're choosing the letters A and B. And the order here doesn't matter. Okay, so it doesn't matter whether we choose B first and then A or A first and then B. It just matters what are the 2 letters we choose. Okay, so we just write down A and B. Now we can also choose, we can keep going. We can choose A and C, right? We can then choose A and D. And I actually want you to just keep going and count. You know, you can actually write them all out, or you could do it mentally. Count what you think the number of choices will be, but I'll just keep writing them down, but you just try to count them, okay? So we can choose A and D, then we can choose A and E. All right, so those are choices. So here, these are all the choices which include A, okay? And then we can choose, so we're not allowed to choose A and A, okay? It has to be two different letters. So then we can choose B. Now, we've already chosen B and A, so we don't want to include B and A as the first one. We want to include B and C, then we want to include B and D, then we want to include B and E. Okay, those are going to be the three choices involving B that don't involve A. Of course, there are four choices involving B. There's the A, B, B, C, B, D, and B, E. Okay, so we're not duplicating choices though. Then we choose C. We've already chosen C and A and C and B, right? C and A is over there and C and B is over here. So we can keep going. We can choose C and D. Then we can choose C and E. And finally, there's going to be one choice with just D and E. So those are going to be the ways of choosing two letters among A, B, C, D, and E. And how many ways are there? So, well, how many different ways are there? Well, there are 4 plus 3 plus 2 plus 1. Right? It's going to be 10. 4 plus 3 plus 2 plus 1 is 10. By the way, I have a video about adding up numbers 1 plus 2 plus 3 plus 4 plus 5 up to anything you like. And if you've seen that, many different ways of doing that. So links of all relevant videos are down in the description below. So check them out if you're interested. Of course, in this video, we're not exactly talking about that, but it sort of comes up here. So the total number is 4 plus 3 plus 2 plus 1, which is 10. So the answer for this 5 choose 2, this is called 5 choose 2. Okay, we read it that way. So we can write it as 5 choose 2 is equal to 10. Okay, so that's the equation. That is what 5 choose 2 is. We've stated it as an answer to a word problem, but we can also write it down as a number. Okay, so that's going to be the answer to 5 choose 2. Now, we can keep going with this method, right? So if you had something like 25 choose 4, imagine the first 25 letters of the alphabet. Imagine A, B, C, D, all the way up to Y. And how many ways are there of choosing 4 letters from that 25? So this is a problem I don't even want to think about because it's just too complicated to just list all the choices. But that's the cool thing in math. We can find it out without listing all of them. And that's what we're going to do here. We're going to now understand what that should be. Okay, so let's just dive right into that and try to understand how to actually find a formula for these that we can apply readily without actually enumerating all the choices. Okay, so one more thing I want to do just to get a feel for this before we dive into the formula, okay, a couple of things that help to get a feel is what happens if you have 1 at the bottom. Okay, so what happens if you write down something like 6 choose 1, or if you write down 12 choose 1, or if you write down 103 choose 1. What are these values going to be? So the word problem here is how many ways are there of choosing one person, let's say, among 6 people. Okay, the committee has only 1 person, or 1 person among 12 people, or 1 person among 103 people. How many different ways are there of choosing? Okay, so here the answer is just, well, the number of ways of choosing 1 person among 6 people is 6. You didn't just choose any of those 6 people, or you could choose any of those 12 people, or you could choose any of those 103 people. So 6 choose 1 is just going to be 6, 12 choose 1 is going to be 12, and 103 choose 1 is just going to be 103. Okay, so there's nothing fancy here. This is the first number that is easy to calculate. And it's going to be, so a general formula. So here, it doesn't matter what the top number is. So we can call it some letter n. It's a variable. The number of ways of choosing 1 person among n people, where n is any number you like, is just going to be n. So we have this equation, n choose 1 is n. So that is a formula. I mean, that is a formula for that specific answer. Of course, it isn't a very interesting formula, you may say, but it's always useful in math. I always find it useful just to think about the very basic things first, get a feel for it, and then the general case of n choose k, it will be a pattern. You know, the pattern starts off at n choose 1, and it grows from there. Okay, so we understand something, it's always powerful. You know, like sometimes it's easy, like sometimes people, once they understand something, they just say, okay, this is obvious. Many people do this. We all do this subconsciously. But I think it's really helpful just to be happy with what you understand, just to keep that in mind, because what you don't understand, you can always kind of derive from what you understand once you observe what the pattern should be. So even if it seems like a simple observation, it always helps. Okay, so let's just dive right into the next observation. So I'm going to tell you the other example. So in general, we can ask sort of what is n choose k, right? So what is n choose k? So here n and k are natural numbers. You know, k can be 1, 2, 3, etc. 1, 2, 3, 4, 5, 6. N can be 1, 2, 3, 4, 5, 6, etc. Generally, n is at least k. I mean, if k is greater than n, then the answer is, well, there isn't really any way of choosing k things from n, right? If you can't choose 100 things from 10. So you'd say it's 0. So we're interested in the case where k is less than or equal to n. Now, we've understood, so 1 less than or equal to k less than or equal to n. We've understood n choose 1. What is the other example of something we can understand? Is we can understand n choose n. How many ways are there of choosing n people from n people? How many ways are there of choosing 10 people from 10 people? Or 30 people from 30 people? The answer is there's only one. Because if you have all the people and you're asking to choose that number of people, you just choose all of them. That's the only way of doing it. So the answer to n choose n is just going to be 1. Okay, so this is the other example of something that's easy to calculate. Another way of thinking, another example of something which we can work out is n choose 0. Okay, so how many ways are there of choosing 0 people from n people? Okay, so how many ways are there of choosing 0 letters from n letters? Let's say n is 10 letters. How many ways are there of choosing, let's say, 0 letters from 10 letters? So here we can, this may again seem like kind of a silly example. It is convenient to sometimes say that this answer is also 1. Okay, there's only one way of choosing 0 letters, just don't choose anything. That's the only way. This is really a convention. It's kind of extending the boundaries because we've sort of said that 1 less than or equal to k less than or equal to n. But it sort of shows you there's a symmetry there, and it also shows you that n choose 1 is n. Okay, and we're going to come back to this point later. But let's now try to get a formula for n choose k. Okay, what is n choose k going to be? Now, I'm going to give you some examples. So maybe let's take some example and try to understand it, and then try to figure out what it should be. So let me write it down as follows. So let's do the following example just to give a feel for it. Let's talk about the case of 10 choose 3. Okay, so generally speaking in math, people don't come up with a formula like n choose k just from scratch. Like you first try to think up some examples, get a feeling for it, and then you get the pattern. So let's just go to 10 choose 3. So what should 10 choose 3 be? This is a number of ways of choosing 3-member committees from 10 people. Okay, that's what it is. Okay, so it's a number of ways of choosing. So I'm going to write hash number of ways of choosing 3-member committees. 3-member committees from 10 people. That is what is 10 choose 3 going to be. Okay, now how do we work this out? So let's try to think about this a bit more abstractly of how we're going to work this out without actually enumerating all of them. Okay, so suppose we're going to choose 3 members. Okay, so we're going to have 3 slots. Okay, so I'm going to write, they're going to be 3 slots, and we want to choose 3-member committees, and each slot has 10 possible people to choose from, right? Now the other thing is that we cannot repeat, right? If we've chosen someone in the first slot, the order doesn't matter. Okay, so just like that letters we counted, we said A, B, and B, A were the same. It doesn't matter what the order is, but let's say we are going to count them in an ordered way. Okay, so we're going to actually say there's going to be a first person, a second person, and a third person. We're going to figure out what that is, and then we're going to figure out what the actual thing should be. Okay, when the ordering doesn't matter. So let's say we want to choose a committee where we say the first person is the highest position, then there's a second person who is just junior to the first person, and a third person who is junior to the second person. Okay, so how many ways are there of choosing the first person if there are 10 people in total? There's going to be 10 ways, right? So there's 10 possible ways of choosing the first person. Okay, so we're going to write, I'm just going to write this as 10. There are 10 choices for the first person, right? Then there are going to be how many choices for the second person once we've chosen the first person. So once you've chosen the first person, you can't choose him anymore, or him or her anymore. You have to choose the second person. You have 9 possible choices, okay? You can't choose for the second person. Once you've chosen the first person, you can't choose them anymore. So you have 9 possible choices for the second person. Now what about the third person? Okay, so for the third person, once you've chosen the first 2 people, you have 10 choices for the first person, 9 choices for the second person. Once you've chosen them, how many possible choices do you have for the third person in your group of 10? Well, you have 8 choices. Okay, so here's the point. This is kind of thinking of this as some kind of tree. Okay, so in the sense of, let's say we had the 10 people, let's label them with letters. Okay, assume that you have the first 10 letters of the alphabet, A, B, C, D, E, F, G, H. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I, J. Okay, these are the 10 letters we're choosing from. Okay, now once you've chosen the first letter, how many choices are there? Well, there are 10 possible choices. It can be anything you like. Okay, then once you've chosen each choice, it doesn't matter what it is, let's say it's D, then you have 9 possible second letters, right? So the first 2 letters, once you've chosen D, you can choose DA, you can choose DB, you can choose DC, DE. You can't choose DD, but you can choose DE, DF, DG, DH, DI, DJ, right? You have all these choices after D, okay? And it's the same for A. Once you've chosen A, you have 9 possible choices. You have B, you have C, you have D, you have E, all the way up to J, right? You have 9 possible choices. Okay, so for each of the possible first choices, you have 9 choices for the second letter, right? So how many possibilities are there in total for the first 2 choices, or the first 2 letters, or the first 2 people on the committee? It's going to be 10 times 9. Because for each of the first choices you have 9, and there are 10 first choices in total, so it's going to be 10 lots of 9, which is 10 times 9. And then for each possible choice of the first and the second people in the committee, the third person, there's 8 choices left. So it's going to be 10 times 9 lots of 8, or 10 times 9 times 8 choices for the 3-member committee, okay, in the order of first, second, and third. Okay, so the answer is going to be, for how many ways are there of choosing a 3-member committee out of 10? And I'm going to be very precise here about what I mean, because it's very important. Okay, so how many ways are there, right? Number of ways of choosing 3 people in order in rank, right? So I'm going to put first, second, third. Number of ways of choosing 3 people in rank, first, second, third, in a 10-member committee. Among 10 people, sorry, write that among 10 people. Among 10 people is equal to 10 times 9 times 8. Okay, that's going to be the answer. You can even work that out. Okay, you can even say that's 90 times 8, which is 720. Okay, you can work that out, but it doesn't, the general principle is 10 times 9 times 8. It's a simple enough pattern. You want to see it's decreasing by 1, 10 times 9 times 8. Now, this is not exactly 10 choose 3. Why is it not 10 choose 3? Because we're not taking into account the fact that there are different possible orderings once you've chosen the 3 people. So when you're counting 3-member committees from 10 people, you're not ranking them. You're just saying 3-member committees. Okay, so if I was choosing letters, it's like saying that if I chose a 3-member committee, suppose I label the people A through J, if I chose A, B, and E, right, and I ranked A as first, B as second, and E as third, well, that's the same committee as ranking B first, A second, and E third, or ranking E first, B second, and A third, or ranking B first, A second, and E second and A third. So let me sort of write that out. So you get the idea. There are many different committees, and then when you rank them, so we've counted how many are there with a specific ranking, right? How many possible 3-member committees are there where you're ranking them, but all these committees with different rankings are actually the same committees. Okay, so there is a certain sense in which we have counted too many choices. Okay, so I'm just going to write out all of the possibilities with A, B, and E actually just to show you very clearly. So let me actually do them side by side. So here we have A, B, E. Then another ranking with A first is we could choose E second and B third. Then another ranking with B first is we could choose E second and A third. Then another ranking with E first is we could choose A second and B third. So there are 6 possible rankings for each 3-member committee. Okay, and what we've counted with the 10 times 9 times 8 is we've counted the number of 3-member committees with specific rankings. So the 720 includes all these 6 choices. For example, okay, I've just chosen the 3 letters A, B, and E. It includes all these 6 choices, right? But they're all the same committee. So we are overcounting basically. We have overcounted the number of committees by counting 720 because all of these things are different counts in 720, but they're really the same 3-member committee because we've counted the committees with a ranking. Okay? Now this may seem a little confusing, but the point is that it's actually simple in the sense that no matter what 3-member committee you choose, there are 6 possible rankings of them. Okay, it's the same principle. It doesn't matter what the letters are. There are basically 3 choices for the first ranking, right? What letter you choose as number 1, there are 3 choices. So for example, here it could be A, B, and E. There are 3 choices for the first ranked member of the committee. Then once you've chosen A as first, there are 2 choices, right, for the second. It could be B and E for A, or if you've chosen E first, it could be A and B. A or B as the second choice. Okay, so the point is that there are 3 choices for the first ranking, then there are 2 choices for the second ranking, then there is 1 choice for the first ranking. So there are 3 times 2 times 1 different rankings of a 3-member committee. Okay, so I'm going to write that in the following way. So I'm going to erase this. Let me erase this here. Okay, so there are going to be 3 times 2 times 1 rankings of 3-member committees. Okay, that's what we found out here. And we're going to get to the answer now. We know there are 10 times 9 times 8 ways of choosing 3 people in rank. Okay, so let's write that down. Among 10 people. Okay, so this is where the 10 matters. Among 10 people, there are 10 times 9 times 8 ways of choosing 3 people in rank. 3 people in rank among 10 people. Okay, so that's there. Now, what that's going to give us is the following formula. Okay, so I'm going to erase this now. And we're going to find out what 10 choose 3 is. Okay, so we're going to find out what 10 choose 3 is. And it's going to give us the general principle for the general question. Okay, so I'm going to write this out as what is 10 choose 3? So 10 choose 3 is the number of ways of choosing 3-member committees from 10 people, right? And if we multiply that by the number of rankings, right? How many ways are there of ranking a 3-member committee? There are going to be 6 ways of ranking a 3-member committee. 3 times 2 times 1, right? So we're going to have 3 times 2 times 1, which we know is 6, times 10 choose 3 is equal to 10 times 9 times 8, which is the number of ranked 3-member committees, right? So the number of 3-member committees is 10 choose 3. Then the number of ways of ranking each committee is 6. So if you have 10 choose 3 different committees, there are going to be 6 times 10 choose 3 different ways of finding 3-member committees that are ranked. And we found that the answer to the number of ways of choosing 3 people in rank or 3-member committees that are ranked is 10 times 9 times 8. So we get the formula that 3 times 2 times 1 times 10 choose 3 is 10 times 9 times 8. Okay, so this is the number of, I can write this out the following. This is the number of rankings This is the number of committees, 3-member committees among 10 people. And this is the number of ranked 3-member committees among 3 people. Ranked, let me write this as ranked 3-member committees among 10 people. So ranked 3-member committees among 10 people. Okay, so number of rankings of 3-member committees. So I want you to just think about this and convince yourself of why this is true. Number of rankings of 3-member committees times number of 3-member committees is equal to the number of ranked 3-member committees among 10 people, okay? And so now we get the formula. You're going to see where this is going, is 10 choose 3. You can divide both sides by 3 times 2 times 1, and you're now going to get 10 times 9 times 8 divided by 3 times 2 times 1. And the reason I've written it this way, instead of just expanded out what the products are, is that this is going to be a general pattern. The same approach is going to work for any of these n choose k's. Okay, but here we get the answer that it's going to be 90 times 8, which is 720, divided by 6, which is equal to 120. Now imagine actually enumerating all the 120 examples. I've explained this for the first time, so this is like a first explanation of what this is. Once you get used to this, this is going to be much faster, but I'm pretty sure that even explaining this, the time it took would have been about the same or even faster than actually writing out all the committees. I mean, if you have 10 letters like A through J, actually writing out all the choices, and it will be much more fun this way because we actually understood why the answer is what it is, and it's going to be 120, okay? So now what I'm going to do is I'm going to give you the general formula for the binomial coefficients, and this is going to use a, so if you have any thoughts, comments, or feedbacks before, please leave a comment down below, and please leave a like and subscribe. It means a lot to me and helps disseminate my videos. If you got this far, it really means a lot to me, and I'm very grateful for your interest and time, and I love making these videos. But now what I'm going to do is I'm going to talk about the n choose k, the general formula for how many ways. So we have n choose k. These are what are called the binomial coefficients. And I'll explain why they're called that in a later video. I think this video I will just explain what the formula is. So n choose k is going to be the number of ways of choosing k-member committees among n people. Okay, k-member committees among n people. So I'm going to write this as k-member committees among n people. Okay, so that's going to be n choose k. So here n and k can be anything. So we just figured out n is 10, k is 3. The number of ways of choosing 3-member committees among 10 people. So we want a formula for this. So we're going to do it in the same way as earlier. We're going to first find out how many ways are there of choosing k people in rank among n people. Okay, so the first one is we're going to choose among n people, or if you like, n letters. Okay, I mean they're not, if n is large, n is like 300, they're not that many letters, but maybe you can think of symbols or pictures or something. Okay, so you're going to have like n people, and you want to choose a k of them. Okay, so they're going to be k choices for a k-member committee, but in rank. You're going to have a first person, you're going to have a second person, you're going to have a third person, all the way up to a kth person. So how many ways are there of choosing k-member committees that are ranked among n people? So what we're going to do is we're going to do it the same way as earlier. We're going to think about how many choices are there for the first person. Okay, so if you have n people, the first person can be any of them, right? There are n people, so there are n possible choices. I'm going to write the number of choices up top like I did earlier. There are n choices for the first person. Now you can always kind of think about the 10 choose 3 as a motivation just to feel for it, or imagine n to be a small number if you like. But it's just the same idea. It's just there are n people in total, so there are n choices for the first person. How many choices are there for the second person? So this is a ranking, k-member rank committee. Well, for the second person, you have n minus 1 choices, right? Whatever n is, if n was 10, it was 9. Okay, whatever n is, it's 1 less than n. So the answer is going to be n minus 1 for the second person. You can't re-choose the first person as the second person. Now you can keep going with this. The third person will be n minus 2. So in our previous example, we stopped there, we were looking at 3-member committees, and we had 10 times 9 times 8. So n was 10. But in general, whatever n is, there are n choices for the first person, n minus 1 choices for the second person, n minus 2 choices for the third person, and all the way up to the kth person. How many choices are there? So it keeps going. It's n for the first, n minus 1 for the second, n minus 2 for the third, n minus 3 for the fourth. So in general, you see the pattern, n minus 4 for the fifth. So for the kth, it's going to be n minus k plus 1. Okay, so just to kind of take stock, the way I feel for this is basically, as I said, for the second person, they're n minus 1. So 1 is 1 less than 2. Okay, so 2 is the second. The third person, so 3, 2 is 1 less than 3. So in general, for the kth person, it should be n minus k minus 1. Which if you write out the, you expand out the minus sign, remember when you have brackets, it's going to be the minus of the minus 1 is plus 1. So it's going to be n minus k plus 1. Okay, so that's going to be the number of choices for the kth person. Okay, so this is going to be the number of ways of choosing a ranked k-member committee. Ranked, okay? So we have ranked them in order, in order of k people. It's going to be n times n minus 1 times n minus 2 times dot 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 times n minus k plus 1. Okay, so that's going to be the formula for the number of ranked k-member committees. So I'm going to write this out here. Number of ranked k-member committees. Okay, so that's the formula. So I'm going to now erase this. So you can check, when k was 3 and n was 10, it was 10 times 9 times 8. n times n minus 1 times n minus 2. But this is a general expression, okay, for what that is. Now, if you have any questions, thoughts, feel free to leave a comment down below. I'd be happy to try my best to answer as many as possible, or even other people can have a discussion, but I'll definitely read your comment and do my best to answer. But that's going to be the number of ranked k-member committees. Now, how many ways are there of ranking k-member committees? Okay, so how many ways are there? Okay, so here's the question. How many number of ways of ranking k people? How many ways are there of ranking k people? So we found out how many ways of ranking 3 people. It was 3 times 2 times 1. How many ways are there of ranking k people? Well, basically, the first person, whoever you decide to be first, they're k choices, right? Because they're k people. The first person has k choices. These counts are very similar conceptually. That's why it looks like it's a product of numbers, It's the same idea. The first choice is going to have k possibilities. Once you've decided who the first person is, if they're k people, there's only k minus 1 left over that you can choose as the second person. You can't re-choose the first person. So you're going to have k times k minus 1. Okay, and then for the third person, you have k minus 3 choices. And so on and so forth, all the way up to, for the second last person, you have 2 people remaining to choose. And then for the last person, they choose themselves because you've already chosen the first k minus 1 people. There's only one choice for the last person. So the answer is going to be, it's like, just like before, it's going to be k times k minus 1 times, this should be k minus 2, not k minus 3. My apologies. So that should be k minus 2. But you see that that's what the product is going to be. And this is a number that I've done videos on this. I've done videos on the factorial. So I encourage you to check that out. Links of all relevant videos are down in the description below. But this is k factorial. This is what we denote by k and an exclamation mark. So for example, you can write down, I'll just write this down. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 5 factorial or 7 factorial, let's just jump up. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, the product of the first 7 numbers is 7 factorial. The product of the first k numbers is k factorial. So it's just another way of writing it. Okay, I've talked about it in another video. There's nothing to it other than that conceptually. That's what it's denoted by. So now we found the number of ways of ranking k people and the number of ranked k member committees. How do we find the number of k member committees in n people? Well, what we have to do is, it's the same idea as we did earlier. So the number of ranked k member committees is an overcount, because many different k member committees that are actually the same, but they just have different rankings, and we are counting them in this count here. Okay, just like before when we had the letters, if we had the letters A, B, and E, we had many different ways of ranking those letters, but they were all the same committee. We had 6 ways of ranking those letters, but they were all the same committee. So we are overcounting. So the actual answer is going to be, and this is going to be the formula, that n choose k, which is the number of k member committees, and I'm going to now erase this from here. So n choose k, so maybe I'll write it out here. N choose k is the number of k member committees times the number of ways of ranking a k member committee. So each committee has k factorial rankings. K times k minus 1 times k minus 2 ... times 1, different rankings. That is going to be, so this is the number of ways of ranking. Okay, number of ways of ranking a k member committee. That is going to equal to the total number of ranked k member committees. Okay, so that is going to equal to this number here that we worked out, which I'm going to write as n times n minus 1, n times n minus 1 times n minus 2 times ... times n minus k plus 1. Okay, so this is going to be the number of ranked k member committees. Okay, so I'm just going to write this as ranked k member committees. Okay, so the number of ways of ranking a k member committee times the number of k member committees is the number of ranked k member committees. Okay, so that's going to be the formula, and now we can find a formula for n choose k. So you see the process, it's a very cool process, just conceptually thinking about what we're counting, and that leads us to the answer. And so n choose k, which I've just said is the number of ways of choosing k member committees. So that's going to be equal to, if we divide both sides by k factorial, that's going to be n times n minus 1 times n minus 2 times ... times n minus k plus 1 divided by k factorial, which is k times k minus 1 times ... times 1. That's the answer. So that's the magic formula for n choose k. And just like we found out n choose 3, you can use this formula to find out anything. I'm just going to do one more step to show you how this is in a familiar form. Okay, so using factorials. So we know that the denominator is what is called k factorial. Now, the numerator is a product of n minus 1, n minus 2, all the way up to n minus k plus 1. Okay, now what you can do is you can write the following. N times n minus 1 times n minus 2 all the way up to n minus k plus 1, right, multiplied by n minus k. So that's the next number. Once you have n minus k plus 1, the number 1 below that is n minus k, right? You subtract 1 times ... Okay, so n minus k, and you keep on multiplying the numbers, n minus k minus 1, ... times 2 times 1. Okay, so you multiply all the numbers up to 1. This is just the product of the first n numbers. So it's what we call n factorial. It's just n times n minus 1 times n minus 2, etc. The reason I say this is because now if we just want to think about this part, which is the top of that formula over there, well, what we can do is we can divide both sides. The product of n minus k minus 1 all the way up to 2 and 1, that is just n minus k factorial, right? So this thing here is just n minus k factorial. So you can think of the general formula is n factorial is equal to basically, okay, maybe I'll write it this way. N times n minus 1 times n minus 2 times dot 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 times n minus k plus 1 is just going to equal to n factorial over n minus k factorial. Another way of writing that in terms of factorials, and now we can write this formula in a very standard way. You know, if you've seen n choose k, if you Google Wikipedia, it's going to show you some formula, and that formula is the following. It's just what we just figured out, but it's in a more standard notation, and we can write it as follows. And I'm just going to end the video with this formula just to show you. So it's n choose k is equal to, it's going to be, the top is going to be n factorial. So I put a bracket there, but I want to put a bracket. So n factorial over n minus k factorial divided by k factorial. And now we can put that in, you know, when you have fractions, you can write it out in the following way. N factorial over k factorial times n minus k factorial. And this is the magic formula for n choose k that, you know, you see everywhere. It's a number of ways of choosing k things from n things. Okay, whatever the things are. Things could be, you know, letters or numbers, or they could also be people, you know, whatever you like. Number of ways of choosing k items, people, objects, things, whatever, from n is going to be n factorial by k factorial times n minus k factorial. Now you can play around with this. You know, I will do another video on Pascal's triangle and the binomial coefficients to explain two other cool ways this come in. These numbers form this beautiful triangle called Pascal's triangle. So links of all relevant videos down in the description below. You know, if you see this later, I'm planning on uploading in sequence, so it may be, if you're seeing this very early, it'll take a little bit, maybe a few days or so, but those videos are coming out. And if you're seeing this and it's a little bit old, you'll definitely see this video that explains more about these coefficients. Links are all down in the description once they're available, which they should be. And so thank you so much for watching. I hope you loved the video on these coefficients. I hope it was comprehensive. It gave you a clear idea of what is n choose k, how to think about it, and how to understand these. And leave comments down below. I love to hear your thoughts, comments, and feedbacks. And if you've watched so far, thank you so much. It means a lot to me. I'm very happy to have you as a supporter of my channel. Just watching is a lot of support. But if you could also leave a like and subscribe, it takes a second, it's free, and it means a lot to me to help disseminate these videos to as many people as possible so everyone can learn from, understand, and benefit from this math, because my goal is just to help everyone to learn, understand, enjoy math, and to just inspire people who may not have the background or, you know, the inclination at the moment, but by watching these videos hopefully can learn to enjoy and appreciate it. So thank you so much. I hope you have a wonderful day wherever you are. I wish you all the best. I'm so happy to make this video. I'm so excited to see you soon. Leave a comment down below. I'd love to engage with you and love to see you soon. So take care, and I'm super excited to see you in the next video.